Hi, everyone. For this session, it is my pleasure to introduce Antoine Bosselut, who is an assistant professor at EPFL. Previously, he was a postdoctoral fellow at Stanford University and a young investigator at the Allen Institute for AI. He received his PhD at the University of Washington in 2020. His research focuses on developing AI reasoning methodologies that can be effectively translated to important societal problems in health, education, and helping underserved communities. He was named as one of the Forbes 30 Under 30 list for science and healthcare in 2021. He is also on the steering committee of the Swiss AI Initiative, Switzerland's largest public initiative to democratize large-scale AI for the benefit of society. Antoine, thank you so much for being here.
Thanks for having me.
So let's get right into it. Around the most exciting thing that you've done recently, the big title topic here, which is Switzerland and Swiss AI recently launched the world's largest open science AI initiative with the Alps supercomputer and the Apertus series of language models. I don't think any project can match the scale and openness of Apertus, and I'm personally what you're doing. So what unique strategic advantages does Switzerland have that you think enabled this ambitious sovereign AI program? And do you think there's characteristics about Switzerland that allowed you to coordinate with over 800 researchers across 10 plus institutions?
So thanks for that great question. Thanks for highlighting Apertus as well. It's kind of a big pride point, I guess, here at EPFL and DTH Zurich and in Switzerland. There's lots of parts to that question, and I guess I'll get kind of the big elephant in the room out of the way. I think one of the strategic advantages that Switzerland had here was access to a very large public supercomputer. So around four years ago, the Swiss government made a fairly large investment into a new supercomputer. This was right around when GPT-3 came out. That was the first kind of very large language model, and the response to that on the Swiss side was, okay, well, if we want to be able to do research and R&D at this scale, we need a resource that would allow us to train models that are this big. And so they invested in around 11,000 GPU chips, which, by today's standards may not be the largest supercomputers when we talk about 5 gigawatt supercomputers nowadays, but was a pretty significant public investment back then into this type of technology. And that's really a huge enabler. At the same time, in order to successfully leverage that resource, there's lots of other things that the Swiss ecosystem brings into play. There's generally quite strong researchers that curate, that are part of a system that curates and attracts talent and that produces kind of great students who are ambitious and want to participate. Coming from a set of public institutions in the academic world, we kind of have a different model to most other LLM development efforts in that we are largely student run. Where ambitious PhD students and master students across our academic institutions, participate quite heavily in the larger project, and that requires finding a system that can, an overall system for the project that can leverage this strength. But it's quite valuable. We have to find our own way, but it's made possible by the strength of the people that we have here. And then, I'd say that the two last points are, one, we have fairly kind of strong institutions and, courageous leaders that had the courage to take a big swing. Academia is generally a fairly conservative institution overall. As an old colleague of mine used to say, we've been around for 800 years, and there's a reason for that. But it takes, I think, quite a bit of courage to try to take on a project of this magnitude, given some of the risks involved, and not all institutions, I think, would have the stomach for that. And then the last thing that I think is a unique advantage in Switzerland is that we're generally a fairly small country, and that creates kind of very close connections between academia and industry. And the projects that we pursue can generate quite a bit of excitement and support in our industrial leaders, and that's great because it creates buy-in from societal and industrial actors they want to see what we're going to create, and that can give confidence to public sector institutions to push forward when you know that you have this interest and this buy-in at the output from the industrial leaders in the area.
That's fantastic. I mean, it is an incredibly bold project, especially considering how transparent and open it is at the scale that you're operating at. And we'll get into that a little bit later. But you did mention the Alps supercomputer, and even though we might compare it to today's scale, it still currently ranks 6th globally, and it's empowered entirely by hydropower, and it has these innovative cooling systems. How does sovereign AI infrastructure like Alps fundamentally change what's possible for AI research compared to relying on things like cloud providers, commercial cloud providers?
It's an absolute game changer, is what I would say, because it's, obviously one thing you could do with a machine like Alps is just do what you were doing before, but more of these, little projects and optimize a few more things, run a few more experiments. And that would be one way to leverage this style of machine. This isn't what we have done, though, in the Swiss AI initiative, where instead, our approach was to say, this machine fundamentally changes the type of research that can be done. We can tackle problems that others can't necessarily touch just due to the magnitude of the training and the compute that we can expend. And so we should really try to do something completely novel, and at a very large scale. And that's what the Apertus project essentially was. Without Alps, we would not be able to do this. Commercial cloud providers, even on the cheapest side, are often something like $2 per GPU hour, and that's dynamic pricing, which is inherently unstable. So if you really wanted to pre-train something at Alps scale, you would need to spend between 15 and 20 million dollars just to run that research project, which I think would be potentially tough to raise through public funding mechanisms and even from corporate actors. With a publicly funded supercomputer, we're able to train for just direct costs such as energy and cooling. And even if you which is a lot less than that, and even if you factor in kind of the original infrastructure CapEx, which is substantial to make a cluster of this magnitude, you're still only coming out to something that's like 40 to 50% of what the cheapest, lowest level commercial rate would be. So, having this type of public infrastructure is a huge enabler to be able to do this.
There's something that feels very uniquely Swiss about that intersection of academia and public infrastructure. And then there's the other piece where this sort of bold step of making everything open and transparent. So Apertus represents a fully open alternative to commercial models, even those with open weights like GPT-OSS or Llama or Qwen. And it's trained on over 1,500 languages with transparent everything, right? Architecture, data, code. So what technical and strategic trade-offs did you navigate to maintain this competitiveness on performance while embracing this kind of unprecedented level of transparency? And how do you think that this openness actually contributes and drives innovation?
Yeah, so there's a lot of parts to that question, and I'll try to take them one by one. Thanks for bringing this up. It's always nice to highlight what makes Apertus different.
I love it.
When we started this project, like I said, there's substantial cost to a project like this, and so we kind of went into it thinking, all right, we need a differentiating factor, something that's not done anywhere else, in order to actually justify, going down this road and creating this scientific and industrial artifact. And so when we came up with essentially 3 thrusts that we wanted to be super important to Apertus. The first, we wanted it to be fully open and transparent, apart from a few notable exceptions, but very impressive notable exceptions such as Olmo and Luther AI and LLM 360. There wasn't really the same focus on open models, and none had been developed at the scale we were working in. The thing is to actually train a model at that scale, make it fully open, and wanting it to kind of be useful to commercial actors, you kind of run the risk that you might get sued if you're not careful about what type of what part of the mixture you show to everybody. There's a reason that many commercial actors and open weight models don't really tell people what they train on. It invites a certain level of let's call it gosh, what's the word, scrutiny. That maybe would not be all that nice. So in our case, because we wanted to make things fully open and transparent, we held ourselves to a very high data compliance standard, where we wanted to make sure that any data that we showed that we trained on would not invite this type of negative reaction. So we only trained on public data sources, for example, from the web, and we made sure that we respected author opt-outs in these web resources when we actually trained on the data. To be able to say that we did not train on data where the authors had specifically opted out of this. And what was kind of special about us as well is that we retroactively applied these author opt-outs. So even if a web page had been crawled because in 2017 the authors hadn't thought that, hey, maybe LLMs will train on this one day, if they had figured that out by January 2025, we said, all right, well, that's not fair game for us. You've made a decision now that you understand the stakes, and we're going to remove that from our training mixture. Naturally, when you start to do something like this, you lose out on a lot of what we might call high quality data sources, content from newspapers and from textbooks and encyclopedias that are actually very high quality data for models to learn capabilities from. And it's, because we don't actually train on these resources, we had to be very careful about trying to very closely measure, okay, what will be the capabilities trade-off, as we do this. And luckily, we didn't measure that big of a capabilities trade-off in trying to respect, all of these data preferences of author owners. There were kind of a few cases where we see some drops, and that generally comes from not training on very large-scale illegal dumps of textbooks and encyclopedias, for example, which those dumps are actually at the center of many court cases right now. We didn't train on them, and we do notice a bit of a capabilities drop related to certain benchmarks that test for that type of knowledge. But benchmarks are one thing, and then the downstream performance of the model for users is another. And generally, we've gotten great feedback, and we have full confidence in this model as a scientific and engineering artifact. And because it's open and transparent, people can trace how the model is learning all of its capabilities through the data, through the checkpoints. And I think that that's going to motivate and inspire a lot of new methods that maybe gets rid of this capabilities gap that we see in some instances. One interesting thing, though, that we found was in terms of the 1,500 languages, there'd been a lot of discussion around the curse of multilinguality, that if you train on other languages, it ruins the model. And you typically don't want to do that because performance on English is so critical. So any multilingual training should never hurt English. We generally found that this really kind of wasn't the case, that actually a lot of times it's from, not applying new languages correctly into a training mixture that actually leads to degradation of performance, but that we didn't see all that much degradation when we, did not kind of make those decisions. And, in our mix, we actually tend to do, fairly well on English level benchmarks. And then we're absolutely superb on, multilingual benchmarks, obviously, since we train on all of these resources. And what's been one of the most inspiring things for me, at the very least, as a result of this project, is the reception of the model by, language communities that tend to be a bit more low resource than typical, and that now finally have a tool that they can build upon, and that they can have confidence actually represents the language resources that they speak.
That's awesome, and that's such for the work that we do. We work on a Thai model, and there is this paradigm of sort of, let's call it English centrality, right? And that kind of finding is actually very motivating, right, for us for us and other low resource language projects to move forward in that way. Like Singapore, AI Singapore, and some of the work that they're doing.
So have you switched everything to Apertus now?
We're looking at it
for Typhoon. Okay.
We're definitely looking at it.
Well, let us know how we can help.
we would love to work with you. Now, one of the things that you mentioned earlier was part of the success of the project is really your connection with with industry, right, in Switzerland, and industry groups there, particularly banking and manufacturing, have welcomed domestic AI work or the domestic AI initiative. And of course, like this kind of work brings data security and regulatory compliance advantages. But what other specific commercial benefits have you observed from doing this kind of sovereign AI development? And again, we're going to talk about trade-offs a few times, but in terms of sovereign AI and commercial solutions, how do you think organizations should evaluate those trade-offs?
Yeah, I mean, I think there's two aspects to that. There's, how those trade-offs should be evaluated today, and how those trade-offs should be evaluated in a potentially different tomorrow. So, there's a whole set of use cases and settings where I would say that are relevant to this today, which is in some sovereign ecosystems, in some sovereign environments. It's just that there's the current offering of commercial models and open weight models are not actually adequate to cater to that environment. You brought up AI Singapore, and I guess there's the Typhoon project as well. These are kind of classic cases of people in a sovereign environment recognizing, hey, these offerings aren't good enough for us, and we need something different, and so we need to actually specialize these models towards our ecosystem, and that I think is the best motivation for these types of tools today. When a model is kind of developed by a small group of people in one environment, and is not necessarily, and that environment is not necessarily exposed to the needs of users in another environment, like there's a gap there, and there's lots of ways to try and fill that gap. And one of those ways is sovereign AI development. I'd say that thinking about tomorrow, there's kind of two other considerations come into play. The first is that sovereign AI, I would say, resets the balance of trade and control over an industry that is essentially critical to the future. As a few examples around the world have shown, global corporations aren't really immune to the whims of the local public sector. And having solutions that are designed and deployed for one's local ecosystems, I think essentially provides a pretty solid hedge to reliance on foreign and commercial alternatives. Even if the local solution right now is not as strong as what you can get, through a global solution, you never know what happens tomorrow. And having a hedge, I think, is a fair thing to do. And then the second point is that if you decide that you need that hedge, and my personal opinion is that most sovereign environments should have that hedge, then you want your local environment to, essentially, breed a group of engineers and researchers that have the know-how, the talent, and the capabilities to actually, keep improving these solutions over time at the same rate as kind of the frontier commercial options. And since, we can kind of view AI as something that's not going away, and that, the next revolution in AI, or the next revolution, perhaps even beyond AI, is likely going to build on the previous one. Each successive kind of digital revolution builds on the same ones. The winners of the AI revolution were the winners of the cloud revolution, 10 years ago. And the winners of the cloud revolution, typically, apart from a few exceptions, were the biggest winners of the web revolution before that. And essentially, the winners of each previous revolution, they stick around for the next one and continue to grow big. So, there's no better time for today for a sovereign entity to essentially try to build its own digital foundations to ride the next revolution more effectively.
Well, Antoine, I really appreciate you making a case for our project as well in that answer, because
I love Typhoon. I love Typhoon.
Thank you. I just being able to look at it on a long view, I think is a critical perspective to have, and the extra work that you put into Apertus to do things like clean up data, to make sure that you're compliant in certain ways, that is such a forward-thinking way to look at this. And again, it's really nice to have another option out there that occupies this kind of space. So I'm going to go to our last sort of trade-off question. And one thing that you mentioned is that the Swiss model prioritizes safety and accessibility for scientific researchers and commerce. And so rather than getting into the arms race of competing with multi-billion-dollar budgets, when you talk to enterprise decision makers or industry decision makers concerned about keeping pace with, the frontier of AI development, how do you balance that kind of bleeding edge capability with, safe, trustworthy, and controllable AI systems?
Yeah, I mean, I think it's a question of perspective, and different institutions have different perspectives on this question. I would think, a perspective I often get from the frontier labs is, AI is going to change everything. Nothing's going to look the same in 10 years anyway. So let's not worry about these little questions, here, because we're going to fundamentally transform everything anyway. And then I'll go and talk to a local industrial player in Switzerland or another European country, and they'll tell me that, oh yeah, we've got to have compliance with the EU AI Act. We may not know what that means right now, but we have some idea. And I asked them, it's like, yeah, but if you try to be compliant, you might get lower performance, lower performing models. And essentially, they don't really care, because a model that is unsafe to deploy for them, but has the greatest capabilities in the world, is not one they can actually put out there. It is, one that they can't use. And so they are willing to take a capabilities hit if it essentially means that they can be confident in the transparency, the responsibility, and the safety of this system. So consumers don't want to deal with unsafe systems. Companies don't want to deploy them, and there's room for both types of systems. Ones that really try to push the frontier no matter what, and then ones that try to come up with a slightly safer, more stable mindset, from first principles. What I'll add is that the gap between these closed frontier models and then open weight models is also getting smaller and smaller. So I'm not necessarily too worried that safe, compliant models aren't going to keep pace with the frontier models, especially, I would say, as that pace does seem to be slowing a tiny bit in the last year.
Don't say that out loud. I don't think we're allowed to say that out loud.
Oh, okay, gosh. Oh dear. I mean, it's an opportunity in my mind. Let's reset the start line, and then we can look towards another finish.
And I appreciate that again, it's a much longer view than sort of like the commercial cycle of what's happening right now, sort of in the tech industry. So I feel like it's a view that you can take advantage of from sort of a position like Swiss AI has, right? Public work, academia. Let's talk a little bit about sort of like your place in Europe. So Switzerland, as Europe pursues digital sovereignty through initiatives like the 200 billion euro AI content plan, how do you think other nations or regions should approach building sovereign AI capabilities like this? So what do you think are lessons from your approach that are most transferable? And then what do you think requires more local adaptation?
I mean, I guess my first lesson is one that's tough to replicate, but build up infrastructure. Apertus was made possible by the fact that a very smart group of people, 4 years ago saw the writing on the wall and made a major infrastructure investment. But I think that does kind of, motivate, I guess, a second lesson, which is that you kind of have to be thinking 5 years, if not more, down the line when it comes to public infrastructure. And kind of adapting and making a plan for where the world is at today, and solely trying to catch up without thinking or planning for where it might be in 5 years is I think a dangerous move. So we should really be investing in what we think infrastructures need to be at 5 years down the line. Now the risk there naturally is that we might be wrong. But then there's ways to potentially de-risk that, particularly in a European context where you have these different poles that could perhaps be investing in infrastructures for different possible outcomes. And rather than just replicating the same thing in all the different places, there's potentially a way that as a continent we could try to make kind of take on a bit more risk and de-risk it across the continent, even if in certain poles, the effort fails, it raises the entire continent. In terms of, what to do in kind of the, immediate term, I would say, define the goals very clearly ahead of time and make the investment if it's worthwhile to pursue those goals and that this is the way to reach them. As I said, for us, we did really put a lot of effort into saying what is going to be our differentiation, and we identified these three thrusts that we were going to do that on. I don't think we would have done that if only decided that there was one of those thrusts we were going to pursue.
It's again, the differentiation is an amazing intersection that puts you at such a great advantage. So the theme here, I guess, for our conversation has really been sort of long view, and looking ahead as we bring it back to sort of the work that you're doing. What do you think enterprise leaders and startup founders should know about accessing and building upon, Switzerland's sovereign AI infrastructure and artifacts that come out of it? And looking at the level of multilinguality and openness that Apertus supports, it's clear that your reach is intended to go beyond Switzerland, beyond Europe, to make it more for a global audience. So are there specific opportunities, partnerships, resources you'd recommend for organizations interested in Swiss AI and this approach to AI development?
Yeah, what I would say is, get in touch with us. Like we said, we specifically designed Apertus so that it would have, a global reach that is built off our local environment. One of the leading institutions is EPFL, where I'm from, and we are less than 45 minutes from Geneva, which is, probably the center of humanitarian action in the world. And so it was always important from us, even with just our local users, that this had to be a global solution. We're interested in kind of bidirectional feedback on this point. So we're, in addition to kind of, continuing to build our development ecosystem, we're also interested in working to build up our deployment and support ecosystems. And if there's parties that are interested in kind of working with us and showing us some real world use cases, we're super interested in that, and we're already kind of fielding quite a few queries. So we're going to be building up kind of community management resources as well. And then the last thing I'll add is, there's obviously this deployment aspect and this technology aspect, but we are also just interested in working with people who are really passionate about LLM development too, and who might be, willing to help evaluate the models, help us train the models, develop data curation strategies. There's a whole development process here that, in version 2 is necessarily going to be bigger than version 1. And while, Apertus is housed in Switzerland, we really view the future of this development ecosystem as being much more global than just Switzerland. So now's a great time to start collaborating with us on that.
Well, Antoine, I look forward to being in touch further and seeing how we can help. And I look forward to think our time. I think our time is up. I just want to say that I'd like to thank Switzerland and Swiss AI and you for bringing Apertus to life and putting it out there. And thank you also very much for your time for joining us.
Well, thanks so much for having me and for letting me chat about what I think is one of the most exciting things I've ever done before. So it's always a pleasure to be able to share what we did.
Awesome. Thanks, Antoine.